And we are going to talk about rational numbers.
Yeah, put it in there.
All right, let's get it in the right spot.
Hey, did you type a piece of paper or are you holding them both?
Okay, yesterday, actually Tuesday, we actually mentioned the word pi
Sit on this side so you can see the board.
and the value of pi, right? I probably talked about two terms, a rational number and an irrational number. Okay, so there's a difference. It's an easy difference, but that's one of the things we want to talk about today. So let's start with things that are rational. If it's rational, you see the word ratio right there? That means it can be written as a ratio. And anything that can be written as a ratio is like a fraction. Okay? A over B, A is any number that's an integer. That's like your positive numbers. Later on in your math life, you could put a negative number up there. And B. But the only thing you can never have on the bottom of a fraction, you can never divide by 0. So B is not allowed to be 0. I mean, think about having 20 cookies and nobody to divide them up, no people. That's not a math problem. That's just 20 cookies sitting in a room. But there's nothing to divide. Now, if you say 20 divided by 10 people, now everybody gets 2 cookies. That's a rational number. That's a ratio. Now, the easiest way to spot a rational number is if you see its decimal. Because we know that every repeating decimal is rational. Repeating decimals, you know, they're predictable. You know what comes next. Do you know any examples of a repeating decimal? Have you seen one before? Nick, what repeating decimal have you seen before?
It has like, if it's a repeating 3, it has a line over it.
Very good. It's a bunch of 3s. It's a repeating 3. If I have 4 3s, can you predict which one would be next?
We are all the way to this box.
Another 3, right?
It just continues.
Yeah, it continues. So, Nick said a repeating 3. Do you know what fraction a repeating 3 is? Anybody know?
What?
What fraction would give you a repeating 3 as a decimal? It's 1 over 3. Yeah, 1/3.
That's what I was thinking of.
That was right. I'm glad you thought that. I wish you would have raised your hand and said it, though. Repeating 3 is a rational number because it's predictable. Do you know what else is rational? A terminating decimal. And we talked about this one earlier in the week. Terminating decimals are decimals that
Are continuous.
not continuous, end. They end. If a decimal comes to an end, then it's a rational number. I bet you can think of a lot of examples of decimals that end, so give me one. Give me a decimal number that ends.
11 divided by 2.
Yeah, you know what? 11 divided by 2 is actually not 0, but let me erase that. It's 5.5. Is 5.5 a decimal?
Yes.
And does it end?
Yes.
It does. It comes to an end. It stops. That means it's terminating. You've heard of an exterminator before. Exterminators are supposed to stop bugs or stop a raccoon from being in your chimney. A terminating decimal, it ends.
If a raccoon was in your chimney, you would have cooked raccoon.
You'd have a problem. Yeah, that's true.
What
Ian?
line of work would you use this in?
What'd you say?
What kind of work would
What
you
line of work?
Yeah.
Well, the reason we talk about rational and irrational is to do any measurement with circles. Because you'll notice repeating is rational and terminating is rational. So the opposite of that, when something is irrational, it means it doesn't terminate and it doesn't repeat. And what's the one decimal we've been using to measure circles that's not repeating and that's not terminating? Pi. right? 3.14. So Ian, if you ever have to measure anything circular, you're going to use an irrational number to do it. You're going to use pi, okay? So if that's making a circular ring or whatever the case may be, let me move down a little bit for irrational, okay? Irrational numbers are decimals that don't end, and they're not predictable. And our best example is 3.14. It does continue 1, 5, 9, 2, but you know what? It doesn't repeat. And it doesn't end. And that's pi. That's a number we use a lot to measure circles.
There's an ending to numbers. Isn't there? No.
Well, you know what the dot, dot, dot means, don't you? Remember, it goes on forever. The other thing I would say, do you remember, is a quick look here. We had a picture the other day that we used to see pi. And if you remember what that one looks like, I'll just take us a moment here. And when I scroll down to this week, which is usually all the way at the bottom, yeah, we had the value of pi. Remember, we talked about it. It does look like 3.14. But remember, it continues.
Oh,
There's
yeah,
the 1592. But then, you know, as you look down the line, I don't see it repeating. And I can't really predict what comes next. If I just stopped you right here, well, I'm not sure if you'd be able to guess what comes next, but you couldn't predict it. Okay? So we really just have a big difference between what's called a rational and irrational number. So let's make a few predictions here at the bottom. I bet you could answer a lot of these now. Number 1, which is terminating? We said terminating comes to an end. Sean, do you know which one of those would be ending or terminating?
A.
I would agree with you. I would say A definitely ends. Number 2, which one repeats? Which is a repeating decimal? Can you predict what comes next, Cody, in one of these? What comes next after the 6, 7, 6, 7, 6, 7? Probably another 67. Probably a bunch of them. Like, that is going to go on and on and on.
I had a question about 3.14.
Sure.
Is there any decimals other than that?
That are irrational?
Yes.
Not as that type of decimal. Now, if you could write a fraction that has a decimal in it, then it's no longer rational.
Like,
But that's our number 1 example.
I was gonna say, so is it any other number that is like 3.14?
Not right now. There's not. Okay. Number 3,
Discover one, Miss Morris.
which is neither terminating or repeating. Haven't heard from some people yet this morning. Darren, I saw you raising your hand. That's a good thing. Which is neither? Number 3. It's not terminating and it's not repeating.
A.
Could you predict what comes next after 185, 185?
185.
So that, you know what that would be called?
That would be repeating.
That would be repeating. And we want that's neither. Try again.
3.
C.
C.
Don't you recognize that? Isn't that pi right there? What would you say B does?
Goes on and
Well, B.
Terminating.
B terminates. What would you say D does?
Repeat.
It repeats. So let's get rid of those options. Okay? So Ian, you also talked about when do we need to use rational? When do we need to use irrational? Well, actually, number 4, if you have 8 over 9, that's a rational number. But you need to know what that means. Does that mean 8 divided by 1/9?
No.
Does that mean 8 divided by 9? Or 9 divided by 1/8? Or 9 divided by 8? Which way does that go, that 8 over 9? Which one, Ian?
B.
Very good. Remember, this is divided by when you have a numerator and a denominator. So the only acceptable answer here is taking 8 and dividing it by 9. Good job, Ian. You're welcome.
I don't understand them.
Number 5 has one way not to describe 3 over 5, which actually means there are 3 ways that does describe it. So, Kyle, you might not be able to pick the one that's not right now, but let's pick one that is a way of describing 3 over 5.
3 divided by 5.
Very good. 3 divided by 5 does describe 3 over 5. So let's get rid of that choice. And now we've only got 2. I should say.
Well, wouldn't it just be D because it's saying...
That's a curious one, D. I don't know. Can you simplify 6 to 10?
Yes, you can.
What would it be?
You add 5 plus 5
Oh,
plus 10 plus 3 equals 6.
So wait a second. Are we saying that 3 out of 5 is the same as 6 out of 10?
Yeah.
So is 3 out of 5 a way to describe the ratio of 6 to 10?
Yeah.
It is. So does that mean that's our choice?
Nope. It means A.
Nope. We're down to 2. 3 parts of each 1/5 or 5 divided by 3. I got a lot of hands up now. Sean, what do you think?
A.
Should we keep it as our choice or get rid of it?
Keep it.
You want to keep it. Sean, did we already cross out C? 3 divided by 5?
B.
So yeah, think about it. How could it be not C, 3 divided by 5, and still not be 5 divided by 3? Aren't those different?
Yeah.
So when you have 3 over 5, can you describe that as 5 divided by 3?
No.
That's the one that's not a way of describing it. Which means I want to show you A. 3 parts of 1/5. Let's start with this. This would be fifths. And what would you tell me if I shaded 3 of them? How would you describe the shaded part? What fraction would you use to describe that, John?
3/5.
You would describe it as 3/5. So actually, A is another way to describe a ratio of 3 to 5. It is 3 parts, each 1/5. So the only choice that's not is B.
These are really tricky questions that I see a lot of kids miss because they don't work it through because they think, oh, I know this one.
Yep, especially with this word not.
Not word.
That's a really small word with a lot of meaning. Okay?
No, it's B.
Mr. Orange.
We just worked all the way through the problem, Mitchell.
What? I thought Mr. Orange. What fraction equals 3.15?
No fraction can. You know why?
Why?
Because it's irrational.
And how do they come up with the? And how do they come up with